In this lecture, we'll discuss about the composition of non-uniformly defined functions. Okay, let's take one question. If fx equal to 1 minus x for x less than equal to 0, x square for x greater than 0, this type of function is known as a defined function. Okay. Also, more precisely, it is non-uniformly defined functions. Okay. Why non-uniformly? Because for different domain there are different functions. Okay, that is for 1 minus x is less than for 1 minus x for x less than or equal to 0. Okay, that is for this branch domain is x less than equal to 0. Similarly, x square for x greater than 0, that's why this function is known as non-uniformly defined functions. Okay, also other function we have gx. Okay, that is minus x for x less than 1, 1 minus x for x greater than or equal to 1. Okay, we have to find here f composite g. Okay, f composite g of x we have to find. So we have two methods here. Okay, one is graphical method, one is analytical method. Okay, graphical method is somewhat simple. Okay, if you know how to draw the graph of any defined functions or any function, okay, then easily you can solve using graphical method. Okay, also analytical method is also very simple. Okay, you can use both the methods, any method to find f composite g or g composite f of any non-uniformly defined functions. Okay, let's discuss about first method, that is method number 1, graphical method. Okay, in this method, the first step is just write down f of gx. Okay, writing f of gx means we have to put gx in the place of x in f function. Okay, clearly this is 1 minus of gx. Okay, and this is for gx less than equal to less than equal to 0, and gx ka whole square, gx ka whole square, and this is for gx greater than 0. Okay, now the next step is we have to draw the graph of gx function. Okay, so next step we'll draw the graph of gx function. For that, just draw one Cartesian coordinate system. Fine. Okay, x y axis, origin. The next step is graph of gx. Okay, now let's review once gs function. gs function is minus x for x less than 1 and 1 minus x for x greater than 1. Okay, this function is defined about x equal to 1 line, no, clearly. Okay, because for x less than 1 and for x greater than or equal to 1, this function is defined. Okay, so we'll draw one line x equal to 1. Just draw the line x equal to 1. Let's take this line as x equal to 1. Okay, so this point is 1 comma 0. Okay, now the first function, the first branch is y equal to minus x. Okay, just we have seen this function. See again, y equal to minus x for x less than 1. Okay, so we'll draw y equal to minus x for x less than 1. So let me draw here y equal to minus x for x less than 1. You know, minus x graph is like this. Okay, this one, clear? Okay, now this is y equal to minus x graph. Okay, and we have to draw for x less than 1. Okay, strictly less than, that's why we should not keep here dark circle. Okay, you should not include this point. Next is y equal to 1 minus x. Okay, y equal to 1 minus x function is having slope slope minus 1, similarly as slope of this y equal to minus x. So definitely y equal to 1 minus x is parallel to this line. Clear? Okay, so we'll draw one line which is parallel to this line. Okay, and passing through 1 comma 0. Definitely no. So if y equal to 0, so clearly x equal to 1 no for 1 minus x. So graph will be like this. Okay, so this is your graph which is 1 minus x, y equal to 1 minus x clearly. Okay, and this point will be included here. Done. Okay, now next step is we have to fill this gx. Okay, gx place. Okay, for this function. Okay, for that you have to check the part of gx which is less than or equal to 0 and which is greater than 0. Okay, see this graph is for gx. No, clearly this graph is for gx. Okay, what is gx less than or equal to 0 means? The part which is lying below x-axis. Okay, and gx greater than 0 means the part which is lying above x-axis. Okay, so we'll write different parts which is lying below x-axis or below, sorry, above x-axis. Okay, so let's write down for gx less than equal to 0. Okay, and let's see the parts here then. For gx less than equal to 0, which parts are there? We have two parts now. Just let me mark these parts here. One part we can see this one. Okay, other part we can see this one. Okay, these two parts are below x-axis. Okay, therefore this is minus x. Okay, and this is for which x? 0 to 1. Okay, you can include 0, but you have to exclude 1 because at 1 the value is not included here. Okay, for this graph. Similarly, 1 minus x function also there for this part. Okay, and this is for x greater than or equal to 1. Clear? Okay, so we have written all the parts which is below x-axis. Okay, similarly, in that function also we have to write for gx greater than 0. No, okay, so for the write down here only for gx greater than 0. Okay, the only part is here, that is this one. Okay, let me mark here this one, this part. Clear? This part is above x-axis. Okay, so clearly minus x, and this is for x less than 0. Okay, we should not include 0 because for x equal to 0, gx is 0, but we should not take gx equal to 0. Okay, because in the branch it is not given. Okay, it is not included in fact. Okay, now we'll fit this branches here for this gx less than equal to 0 and gx greater than 0 in this f of gx. Okay, so let me write here first of all f of gx again. Therefore f of gx we have here from above 1 minus of gx. Okay, this is for gx less than equal to 0. Okay, and gx ka whole square. Okay, and this is for gx less than 0. Clear? Okay, now just feed the values of gx here. See, for this gx less than equal to 0 part, okay, we have two different parts. Okay, we'll fill these parts here. Okay, so 1 minus of minus x. Okay, and this is for which x? 0 to 1. Okay, again we have to fill this next part, 1 minus of 1 minus x. Okay, and this is for x greater than or equal to 1. Clear? Okay, next part is we have minus x. In the place of gx we'll put minus x, and this is for this branch. No, clearly we can see it. Okay, so minus x ka whole square. Okay, and this is for x less than 0. Okay, so just rewrite this function again. So this is 1 plus of x, and this is for x between 0 to 1, x for x greater than or equal to 1. Okay, and x square, this is for x less than 0. Done? Okay, now we can study about this function further. Okay, let's draw the graph of this function. So while drawing the graph of this function, let me write graph of f composite gx. Okay, we'll draw Cartesian coordinate system. Okay, again you have to draw one line, that is x equal to 1, because the function is defined about that line. Okay, so this is x equal to 1. Okay, clearly we have one function here, that is 1 plus x for x between 0 to 1. Okay, clearly 1 plus x function means this one. We should not take whole branch, okay, whole part. You have to take only for 0 to 1. Okay, we know this part is 0 to 1. Okay, so now this is 0 comma 1, no, definitely, and this is 1 comma 0, sorry, not 0 comma 1, this is 1 comma 0, the point on x-axis. Okay, and we have to include this point and we have to exclude this point here, because in the function it is showing that for x is greater than or equal to 0 and x is definitely strictly less than 1. Okay, now next part, we have here x, y equal to x for x greater than or equal to 1. Clearly y equal to x graph we know. Okay, and we have to take for x greater than or equal to 1. So only the graph will originate from here, somewhere here. Okay, like this, and this will be definitely parallel to this graph, this branch. Okay, because the slope is 1 also here, and we have to include this point, we can, because x is greater than or equal to 1. Okay, just write the equation here. This is y equal to x, this is y equal to 1 plus x. Okay, now next is next graph is y equal to x square, and this is for x less than 0. Okay, y equal to x square graph is very easy. Okay, we have drawn many times. Okay, this graph, and you have to exclude here also. Okay, open circle. This is y equal to x square. Clear? So we have drawn 1 plus x graph for 0 to 1, x graph, y equal to x graph for 1 to infinity. Okay, and this x square graph for x less than 0. Okay, so this is the complete graph of this f of gx. Okay, what can you say about this function then? What can you predict about this function? Okay, so see, one thing definitely we can say, this function is discontinuous. Okay, so f composite g x is discontinuous function. Discontinuous function. Okay, and discontinuous at which points? Clearly x equal to 0 and x equal to 1. Done. Okay, next thing we can predict here, also f composite g function is non-differentiable. Okay, that is f composite g is differentiable everywhere except 0 or 1. See, this function is x square, this is always differentiable. Okay, this function is both the functions are polynomials. Okay, and all the polynomial functions are always differentiable. Okay, then but graph is breaking at this point 0 or 1, it is just discontinuous, so definitely this f composite g function is also not differentiable. Okay, at these points. Okay, so we can write here f composite gx is also not differentiable at x equal to 0 comma 1. Okay, in other way we can say f composite g is always differentiable except x equal to 0 or 1. Understood? Okay, now next point we can mark here. See, you know one-on function. Do you have any idea about one-on function? What is one-on function? How can you predict by seeing the graph? Okay, we'll draw a line parallel to x-axis. Okay, let's draw one line here. Okay, suppose this line parallel to x-axis. Clearly, this line is cutting this graph at 3 points. See, 1, 2, 3. Okay, it means for 3 different values of x. See, for 3 different values of x, that is for x1, for x2, and for x3. Okay, for 3 different values of x, there is same value of y. Okay, let's take this value, this point as this graph as y equal to b. Let's suppose this as y equal to b. Okay, so clearly we can say f of x1 equal to f of x2 equal to f of x3, okay, equal to b. Okay, that is, for different pre-images we have a single image. Okay, it means the function is many one. Okay, so also we can say, therefore f composite g is, okay, this is not f of x1 simply, this is f composite g of x1. Okay, let me write like this. Okay, x1 f composite g x2 f composite g x3. Okay, this all has having value b. Okay, so therefore f composite g is many one function. Done. Okay, so if function is many one, so it is non-invertible function. Okay, also, so next point we can write about this function is this function is f composite g is non-invertible. Invertible. Sorry. Done. Okay, many more things you can predict from the graph. Okay, similarly, you can find g composite f also. Okay, this is your homework. Okay, you try once this g composite f. Okay, by the same method. Okay, now we'll discuss about the next method, that is method number 2. See, method number 2. Okay, that is analytical method. Okay, this is also very easy method. Let's write the function again. See, f x we have given as fx function is given. Let me check the function. Yes, function is 1 minus x for x less than equal to 0, and x square for x greater than 0. Okay, and gx function we have here minus x for x less than 1. Okay, and 1 minus x for x greater than or equal to 1. Okay, and we have to find f of gx. Okay, now what is the process? Okay, now see, to find f composite g, just see carefully. Okay, f composite gx. Okay, what we'll do now, first of all, just see gx here. Gx is minus x for x less than 1. Okay, and 1 minus x for x greater than equal to 1. Okay, see, first of all, we'll put this minus x in this fx. Okay, in both the branches. Okay, see, while putting this minus x, we'll put minus x in every place. Okay, every in the place of x everywhere. I mean to say, in the place of x everywhere. Okay, 1 minus of here minus x. Okay, here also minus x less than equal to 0. Okay, and we have to intersect this interval with x less than 1. Okay, interval of this function. Okay, now just put this minus x also with this one. Okay, minus x ka whole square. Okay, and this is for minus x greater than 0. We'll put minus x in the place of x, and also we'll intersect with x less than 1. Same thing here. Okay, now we'll put 1 minus x in the place of this x everywhere in fx. Okay, so 1 minus of 1 minus x. Okay, and this is for 1 minus x. Okay, we'll put 1 minus x everywhere. Okay, 1 minus x less than equal to 0 and x greater than or equal to 1. Okay, the domain of this function. Similarly, next is 1 minus x ka whole square. We'll put 1 minus x here also. Okay, so we'll get 1 minus x greater than 0. Okay, and x greater than or equal to 1. Okay, so again, what we have done here, let's discuss again. See what we'll do. Suppose you have to find f of gx. Okay, then what we'll do now? We'll take any branch. Okay, I have taken first branch here. Gx equal to minus x for x less than 1. Okay, for that we'll put minus x everywhere in fx. Okay, suppose I'm putting in first branch, so 1 minus of minus x. Okay, we'll put this minus x in the place of x here also, less than equal to 0, and we have to intersect this value with the interval of this one. Okay, again we'll put this value here also. Okay, and again we'll keep same thing here. Okay, again intersection with x less than 1. Same thing we'll do with this also. 1 minus x we put here. Okay, next what we'll do here, 1 minus x less than or equal to 0, and we will intersect with this domain. Okay, again here 1 minus x ka whole square. This is for 1 minus x greater than 0. Okay, we'll intersect with this value again. Okay, now we'll find the intersection and we'll write the functions here. Okay, let's see. This is 1 plus x. Okay, what is the intersection of these two? This is x greater than or equal to 0. Okay, we'll multiply with minus 1 on both sides. And this is x less than 1. So clearly this is x between 0 to 1. Done. Now this is x square. So can you find intersection here? This is x less than 0 and this is x less than 1. So intersection is x less than 0. Okay, this is x. See, this function is x here. Okay, now from here clearly x is greater than or equal to 1. You can check. See, this is x greater than or equal to 1. Okay, this part clear, and this is also x greater than or equal to 1. Okay, the intersection is x greater than or equal to 1. Okay, now 1 minus x ka whole square. Okay, now find the intersection here. This is x less than 1 and this is x greater than or equal to 1. Is there an intersection? No. Okay, so x belongs to 5. Okay, so there is no any domain, okay, for this part. Okay, so this part is invalid. Okay, so let's rewrite the function again, what we got here. Therefore f composite g function is 1 plus x for x between 0 to 1, x square for x less than 0, and x for x greater than or equal to 1. Okay, let's match this function with the answer we got earlier. See, we got here 1 plus x for x between 0 to 1. Let's see this one. Yes, 1 plus x for x between 0 to 1. Again, next branch we have above we got here x for x greater than equal to 1. Just see, x for x greater than equal to 1, and x square for x less than 0, x square for x less than 0. Okay, same answer we got here also. Okay, done. Your homework is G composite f. Let's try to find G composite f by both the methods. Okay, both the methods are easy, very easy. You can apply any method in examination. Okay, thank you.